Hello, my name is Clifford Jordan. I'm with Science Foresight, and we're going to have a lesson today about normal distribution. Okay, this is part of, or a precursor, prerequisite you might say, to our series on data science linear regressions. Okay, which is the first big lesson that we're going to have. It's going to be a number of different videos just talking about linear regressions. But before we actually get into the meat of linear regressions, there's a couple things you need to know. One is the slope y-intercept formula, which is another video on that. So if you don't know that, you want to study up on that. And the other thing that you need to know before we get into linear regressions is normal distribution. All right, so let's get into normal distribution. And to do that, let's go over here to this graph here. Now you've seen this graph before. And you probably saw this in high school statistics, or you may saw it in college statistics, or maybe someone just says, hey, this is a cool graph, you should look at it, you should memorize it. It is also known as the bell curve because it's shaped like a bell, right? Well, along the x-axis here, this is just the x-axis. You notice it says 0 here, and then it goes +1 sigma, that little scurly symbol, or actually maybe it's this way. No, this way. Yeah. Anyways, that little symbol is called a sigma, and sigma stands for standard deviation. Notice up here it says x mean, okay, with that bar above it. That means the average of x. So to understand this curve, let me give you a little example of how we would use this. Suppose that I do a polling. I go out on the street and randomly pick 1,000 people and say, open up your wallets or your purses and show me how much money you have inside your wallets or purses. Okay? Now, let's say we took an average of that. If we took an average, and let's just say that it was $50. Okay? What this means is that the average would be right here, $50. For people that have more than $50 or anything this side of that would be more than $50, and anything this side on the left side would be less than $50. Okay, and then let's say we took all these values that everyone had of money inside their wallets and purses, and we calculated the mean. Okay, we got that $50, but we also calculated the standard deviation. I'm not going to go into how you calculate the standard deviation, but it is a number that you can calculate just like you calculate the mean that kind of helps you understand the distribution. Okay. And usually it's less than the mean, okay? And in our case, in our example, let's make it $15, okay? So what that means is that if I go to the left, minus 1 standard deviation, which is what we see here, what that means is this amount here would be 50 minus 15, which would be $35. So $35 would be right about here. If I go this side, that would be 50 plus 15, or $65. If I go another 15, that would be $80. If I go another 15, it would be 95, and another one would be 110. 95, yeah, 110, and so on. Okay. Now the height of this has to do with the number of people that would have that approximate amount of money. Now, if you have a normal distribution, which a lot of things are, and in our example, let's suppose that it's a normal distribution, most of the people would have money in their wallets and purses that is close to $50. And the further I go away from $50, the fewer number of people that have that amount. So as I go to $65, there'd be fewer people that have $65. If I go to $80, there'd be fewer people. And 95 would be even fewer, and so on and so on. You know, if I get out to $1,000, way off the chart here, very few people, maybe one. How about $1 million? Is it possible someone would have $1 million in their wallet in cash? It wouldn't fit inside a normal wallet, but if they had a super big purse, maybe. But the chances are extremely small that we would find that. If we go to the other side, so this is 50, if we go down to 35, we're going to have fewer people with 35. If we go down to 20, that's even fewer people. If we go down to $5, even fewer people. If I go another standard deviation, 5 minus 15 would be negative 10. We got a problem there. You can't have negative money in your wallet. It's impossible. You know, it doesn't exist yet. So there's a limit. The limit is 0. Okay, so we would go from $5 to 0, and then what we would probably see is a bump here where people would a bunch of people would have $0 in the wallet. But everything greater than 0 would probably follow this normal distribution. Okay, so the height is the number of people, and this would be, most of them would be right around here at 50, and then as we go out, it get less, or we go this way, it gets less as well. All right, the cool thing about standard deviations and means or normal distributions is that all I need are these two things, the mean and the standard deviation. With that, I can make some marvelous predictions. One of the predictions that I can predict is that between 1 minus 1 standard deviation and 1 standard deviation, I've got 68% of the people are fit right in between $35 and $65 in their wallet. And if you notice right here, it says between 0 and minus 1 standard deviation, it says 30.3413, which means 34.13% of the population fit in this area right here, this whole area. On this side, another 34.13% fit between 0 and plus 1 standard deviation, so another 34% right here. So between this and this, that's a total of 68% of the people are right in between $35 and $65. If I go to 2 standard deviations, if you notice up here, it goes to, this is like 1.98 standard deviations, which is close to 2, and minus 1.98, which is close to 2. That accounts for 95% of all the people are within 2 standard deviations of the mean. So that means between $20 and $80, okay? Accounts for 95% of people have that amount of money in their wallet. Now, if I go 3 standard deviations between $5 and $95, and that accounts for 99.9% of the people. Beyond that, it's just very few of the people. And so that's the cool thing about the bell curve. Now let me show you an actual example using some data in a spreadsheet. So to do that, what we're going to do is go over here and let's transfer right here. Okay, so what I have here is a table of data, wallet amount, and this is the person. There's 1,000 of these. And here what I can do is I can set what my expected mean is. So I'm setting it to 50, standard deviation is 15, and if you want I could put it to something else like 100 and hit F9, and what it does is it recalculates everything and creates a normal distribution where the mean is 100 and the standard deviation is 15. But for our example, let's keep it at 50, and so let me hit F9 and it recalculates it. Now what we see here is it calculates, it creates this normalized set of sample data, and then it measures the mean, and the measured mean is 53.41, which is really close to our 50, and the measured standard deviation is 15.71, which is close to what we had tried to program into it. I can remember there's a lot of randomness when it figures this out. So what we've done here is here I can, or it shows you the well, first off, let's look at the graph here. This shows you the distribution, the number of people in each 5% segment from the mean. So if the mean is 50, 5% is $2.5. So in this segment from minus 0.5 or minus 5 to 0%, that is from $47.50 to $50. I've got 83 people that have that amount of money. From 0 to 5%, it was between $50 and $52.50. I've got 77 people there. Okay, so if you just keep going out every $2.50, and it tells you how many people are in there. Now I've got some brown bars, I got some blue bars. The brown bars, ignore for right now, I'll tell you that in about 2 minutes. The blue bars is the full distribution, all the way from the smallest amount to the largest amount. Okay, and so it tells you, you can see this nice kind of bell curve. We got a couple little hiccups over here, but hey, this is a randomized selection, so you're gonna have some hiccups, and this is a lot closer to what real life is. All right, so what I'm going to do now is test this whole theory out. If I put 1 standard deviation here, and I'm going to say, okay, hit F9. Oh, excuse me. Hit F9, and when I hit F9, it re-randomizes everything. Now my mean is 52, my standard deviation is 15. if I say I want to measure how many people are within one standard deviation below and above, I put in that 1 like I did, and it then calculated, says, okay, below 1 standard deviation, that would be $37.05. 1 standard deviation above would be $67.40, which is 52.23 plus 15.18 is 67.40, and then 37 is 52.23 minus the 15.18. Okay, so between those two limits, it goes and it says, is this amount between this limit and this limit? Is this, and it is, so it puts a 1. Is this amount between that limit and it? It is not, so it puts a 0. So it figures out, of those 1,000 people, which ones are within these two limits, and then it counts it up and it says we've got 675 people out of 1,000 that are within 1 standard deviation of the mean, okay, which accounts for 67.5%. Now remember, according to our bell curve that we saw before, in theory, within 1 standard deviation below and above, we should have 68% of the people. Well, in this little trial here, I'm getting 67.5, okay, which is a good indication that indeed this works, okay. Now, let me move this down just a little bit because I can't see that. So, let's try 2 standard deviations, all right. So we're going to try 2.00, hit F9, and bingo. That's going to put us between 1786 and 7981. By the way, the brown lines, which I didn't tell you what they mean, or the brown bars, is the number of people that fit between these two limits, okay? And so you can see that 2 standard deviations goes from this point all the way to this point, okay? And it accounts for 2 standard deviations between this point and this point, or between this amount of money and this amount of money. I found 962 people, which is 96.2%. Now remember, we had calculated that it should be around 95%, okay? So 96.2 is really close. Let's try real quick 3 standard deviations, 3.00, hit F9, and that accounts for 993 people out of 1,000, or 99.3%, which is the vast majority. And so you see the bars go all the way from really low to really high. All of these people fit between $6 and $89. Now, let's say you said, hey, Cliff, I only want to find out what are the limits for, I want 70% of the people. In other words, I want to find how many standard deviations is 70% of the people fit in, okay? What's the standard deviation from the mean where 70% of the people fit in there? What I can do, if you go over here, let's just type in 70%, 0.70. And then I'm going to hit F9. And what it's going to do, it's going to calculate right here. So 0.70 is equal to 1.037 standard deviations. So now if I go over here and type 1.037 and hit F9, it found between this low and this high, which is 1.037 standard deviations below and above, it found 753 people, which is 75.3%. Now it's a little bit high, but it's not perfect. I would say if we randomized again, we'd get a little bit closer. Oh, well, actually we went now a little bit low to 68%, 680. So it's kind of bouncing around there. So here we got 71%. The bottom line is this: we can use the fact that the data follows this normal distribution. We can use that to make some predictions about the distribution of the data. And that is the beauty, and it really is. It's a beauty of a normal distribution. All right, that said, we've reviewed this. Now it's time. You should be ready. If you've gone through the point slope or the slope y-intercept formula video, then you should be ready for to begin studying linear regressions. All right. So until then, have fun, and let's get me down there. Oh, there I am. Until then, I hope to see you in the linear regressions videos. Ciao.